Do safety devices change impulse? This is a question you need to be able to answer. Do safety devices like an airbag, or simply giving as you catch a water balloon, or bending your knees as you jump from a tree, does that change the amount of impulse used to stop a person? It would seem to decrease it. To say, man, when I use a safety device, probably the impulse is lower. Um, but in fact, that's not the case. The answer is no. Safety devices do not change impulse. The reason is that what a safety device does is, and write this down, safety devices increase impact time. You know that. And what else do they decrease? And decrease force. But F times T, when one goes up and the other goes down, F times T works out to the same amount. So when you multiply those two, if one's larger and then one gets smaller, they multiply to the same impulse. So here's an example of an airbag. I'm going to use some fake numbers in this example. No airbag dangerous, with airbag safe. Write this down, right? So with no airbag, there's more force and less time. But with an airbag, there's less force and more time of impact. But when you multiply force and time with or without an airbag, you always get the same impulse. Alright, so maybe you start out with a force of, let's say time is like 2 and force is like 1,000. So your impulse would be 2 times 1,000, so 2,000. I don't even care about units right now, just look at the numbers. So if I doubled my time to 4, then my force always goes down by the same amount that my time increases by. So with an airbag, maybe it doubles the time, so the force halves, and it goes down to 500, right? To make the same impulse. And that's the way all safety devices work, is that they increase the force, they decrease the force, right? And they increase the time in the same amount, but the impulse stays constant. Safety devices do not change impulse. Why? Why do safety devices not change impulse? So here's an example of the airbag. Adding an airbag does not change a car's mass or velocity. So because M stays the same when you add an airbag and V stays the same, that means when you multiply those two, delta P stays the same. And who's delta P equal to? That's right, impulse. So really, keeping M and V the same locks in delta P and locks in impulse. Alright? And so if you had a safety device, maybe there's more time, but because impulse is locked in, force has to go down to make the same impulse. Alright? Here's our stays the same chain, right? Mass and velocity, if those stay the same, then the change of momentum of the car needed when it stops and hits a wall will be the same, and the impulse used to stop it will be the same as well. Now, you could kind of think what's going to come next is, when would a car need more impulse to stop it? So, just like we saw before, locking in M and V locks in impulse. Alright? So changing M and V would change impulse. So when would a car need more impulse to stop it? When a car's mass or velocity, and I'm just using a car as an example of an object, increases. When mass or velocity gets larger, then the car's going to have more momentum. So if either of those go up, then delta P goes up, and then impulse needed will go up. So the only way to need more impulse to stop something is if something, instead of a car, was a truck, more mass. Or if you stepped on that gas and you're going 100 miles per hour instead of 60, you have more velocity. In those two cases, if you're a truck or you're going faster, you're going to have more momentum, and then you'll need more impulse to stop you. But an airbag doesn't increase mass, doesn't increase velocity. It locks in delta P, it locks in momentum, and it just fiddles with these two right here, force and time, to make the same impulse every time. All right.